This is a continuation of our notes on using the 5 equations of kinematics. Okay, this is example 4. So a cruise ship can accelerate at 0.01 meters per second squared if it starts from rest. How long does it take to reach a speed of 25 kilometers per hour? Okay, and then it asks how long would it take if it started from a speed of 2 meters per second. Okay, so this is a two-part. So first, we're just going to address accelerating at 0.01 meters per second squared, trying to reach a speed of 25 kilometers per hour. Okay, so let's start by drawing our diagram. So if we have a boat, okay, it's traveling along. Its acceleration for this part is 0.01 meters per second squared. Its final velocity is going to be 25 kilometers per hour. Okay, and we started from rest. Okay, which means that our initial velocity is 0 meters per second. Okay, and it wants to know how long. So if we look at the different variables, we have that V1 is 0 meters per second, V2 is 25 kilometers per hour. Okay, acceleration is 0.01 meters per second squared, and then we want to know the time that it takes in order to reach that. Okay, now a big problem that we haven't encountered before is that these units do not match the rest of the problem. So the first thing we need to address is changing the units of the final velocity to meters per second. Okay, so if I go through and do that, I have 25 kilometers per 1 hour times, there's 1,000 meters in 1 kilometer, and in 1 hour there is 3,600 seconds. And so when we multiply across and then divide, you should get 6.94 meters per second. Okay, so that is our value for the final velocity in terms of meters per second. Okay, so we have our 4 variables, and so if you look, we do not have delta D, so we don't have displacement. So using the equation V2 equals V1 plus A delta T. Okay, when we arrange it to solve for delta T, you should get V2 minus V1 all over A. Right, so plugging in the information that we know, our final velocity is 6.94. Remember to use the meters per second one, minus our initial velocity, which is 0, all divided by our acceleration, which is 0.01. Okay, and we will get that our delta T is 694.4 seconds. Okay, and to put this in terms that are meaningful to us, we can change it to minutes. So we put this over 1. There are 60 seconds in 1 minute. And so we should get 11.57 minutes. Okay, and generally I will always tell you for the problem that I want an answer in a particular unit. Okay, so moving on to part 2, we have the same values except that our acceleration is now at 2 instead of at 0.01 meters per second squared. Oh, that's wrong. Sorry, I read it wrong. The acceleration is still the same, but your initial speed is changing to 2. Okay, so here started from a speed of 2 meters per second. So that is our new initial. So our new initial velocity V1 is going to be 2 meters per second. Okay, so we're going to be using the same equation. So luckily I already solved for delta t equals V2 minus V1 all over A. So plugging in the known values, we get 6.94 meters per second minus our new initial velocity, which is 2.0 meters per second, all divided by our acceleration, which is 0.01 meters per second squared. So our delta t is 494.4 seconds. And then if we convert this into minutes, we get 8.24 minutes. Okay. So problem solving strategies, this is just kind of reviewing over the things that we talked about at the beginning of this section. So drawing a diagram, it helps you visualize the situation. This is going to become very important whenever we get into more of like the 2D kinematics and things like that. Okay, so actually drawing the diagram helps you to visualize the situation, and it also helps to remind you to determine positive and negative direction. Okay. The second problem solving strategy is write out the values. Okay, so organizing your thoughts into writing down the variables that you have. This makes it easier to determine, one, what equation you're going to use, and then helps you see if you have any gaps. Okay, so like on the one problem that we did, we were missing one of the values, so we had to go back and read and realize that it was telling us that it was starting from stop. So our initial velocity was 0. Okay. The next is choosing the equation. So I would advise that you always have the equation list handy. Okay, and I will always provide you the equations list, like if we were having the tests in school, I would give you the equations. So just make sure that you know how to read them and use them properly. And like I said, you have to make sure that you have 3 of the variables in order to find the 4th. Okay, and just some general tips. Look for keywords like from rest, which means that our initial velocity is 0, or to a stop, which means that our final velocity is going to be 0, okay, because they're coming to a stop. Make sure to check that all units match before you actually start subbing numbers into an equation. Just like we practiced on the example number 4, we had to change the units before actually solving the equation. Okay. And if the question does not indicate units, use logic, okay? So for example, if like, for example, whenever the previous question where we had the seconds, we had 494.4 seconds. That's not a very useful term to us. It's more helpful to convert that. Most of the time I will, like I said, be telling you that I want an answer in a certain unit. So then you would convert it from there.